Now we're going to look at determining the domain of a composition. And this is not as straightforward as an algebra of functions. The reason is that when you compose, you must take into account the domain of the function, okay, being placed into the other, the range of that function, and how that meshes with domain of the other function. I know I'm reading this and it goes, gosh, it's hard to follow. And that's why you should kind of write like a little map. Here are the steps I hope you try to understand, not just follow blindly. What is the domain of f of x? So there's two processes. Here's a very 1, 2, 3, and it seems very straightforward, but it's not very illuminating. So this is the steps that are sort of outlined in your book, and this is definitely more illuminating and more in line with what I showed you in that picture. So if I look at this and again try to create a nice little picture of it, and again, mathematicians always work in pictures. So gosh, I don't want to, can I just get the process and just be done with it? And the answer is, well, yeah, but mathematicians don't work this way. They always are drawing little pictures. So even those little pictures, do mathematicians draw pictures? Absolutely, they draw pictures. They try to have to make sense of what the heck they're doing. So these are acts and they have to make sense. So pictures sometimes do help us. So again, G gets X first and then F gets a hold of that. So that's the process here. So what this says is determine the domain of G of X. Okay, and I wrote it relative to what you see here. So in other words, I need to find not G of X, but really the first function. This is the first function getting X. Okay, so that's really, I know you can barely see that, but that's what you want to get a hold of. Okay, so it's the first function getting X. That's what this G of X represents, the first thing. So now I have this, again, nicely matching what I have here. Looks like G of X is going to get the first crack at this. So if I want to find the domain of this, I need to find domain of G of X. Not because the G is anything special, but it's because that is the first function getting a hold of my input. So I can see that it's a square root function. If you recall, you cannot have a negative number inside the square root. The smallest it can be is 0. So in that case, this whole thing, x plus 2, must either be equal to or greater than 0. So I solve, subtract 2 from both sides. And when I do that, I get negative 2, and that is the domain of G of X. In other words, the only thing that's going to go inside this function right now, if I were to draw a nice little picture of it, I could draw this time G. Here's my input. And what this is saying is currently, this is the only thing that's going to be allowed in here. Okay, and that's going to now feed this another function, f. That's great. But now I have to worry about another thing. Now, what is the other thing I need to worry about? Well, the thing's coming out of here, the output. It's going to get fed to f, but f may have restrictions. What if the output here going into f, it's not amenable to f? F doesn't like it. Like, I don't like those things. So that means I need to come back over here and further restrict this. So right now, this says this is what G likes, but what does F like? That's what we're trying to figure out. So now let's talk about F a little bit. What does F like? Is it particular? It's like a kid eating, right? They're particular. So now we have this function, and we ask ourselves, what is the domain of this function? So again, we have division. The numerator is, of course, a constant, so that's not a problem. The denominator is just x minus 1, that's linear. So there's no problem here. This is all real numbers for the denominator. But now we look at the last operation, which is the fraction. And the fraction, well, we cannot have 0 in the denominator or fraction. So the only domain problem is due to the fact that this is a fraction. The two functions are fine. And so we're going to figure out what causes the denominator to be equal to 0 and exclude that. And it turns out that when I solve x minus 1 equals 0, I get x equals 1. So basically, what we're saying is x equals 1. So x equals 1 cannot go in here. In other words, and this is where it gets a little iffy. I hate this part, but that we call the inputs always x. It might be confused from this x. I'm going to just call it y for a second to be a rebel. But definitely the output here, which is in the form of some y, can't feed it to x, okay? That's not possible. But another question becomes, what causes, what value of x here causes y to equal 1? Okay, so before we were asking, hey, what value of x causes this to be a 0? Now we're asking the question, and turn out to be a 1. So now we're backing this up 1 and asking, hey, what value of x causes this to be a 1? And we exclude that. So now we need to back up this trailer and think about what comes next. So now I'm back to this again. So I need to look now. Notice before I can just devote myself to the very specific problem with this function, which is this inside part, the radican. And I hope I remember that correctly. Embarrassing if I did not remember that correctly. But x plus 2 greater than 0. But now this is different. I need to look at the entire function. So what causes this thing to equal 1? Because after all, when I've entered here into the variable, I need to think this g is going to get everything. So I need to figure out now what causes this thing to be a 1. Okay, so I'm going to square both sides. Notice I left this alone and showed this thing being squared, and I get x plus 2 here, and I get 1. Great. Now I need to subtract 2 from both sides. Again, notice I left this output alone and showed what I just said verbally. Subtract 2 from both sides. And I get negative 1. Negative 1. So it turns out I cannot feed into negative 1. So before, there were two problems. X had to be greater than negative 2, and that is due to g's particular eating habits. But now it turns out that f had its own little eating habits, and I cannot accept a 1. But it turns out that if I feed a negative 1 into g, it will produce a 1. So now we're ready to put the whole thing together. So this input here, the x here cannot be equal negative 1. If it's confusing, just draw like a big number line here again. That makes it simple to put everything together. So now really it's about, okay, what you found in step 4, determine the g of x. Step 6, determine what values of x and g of x that produce the right values to input into f of x. Okay, so it turns out that 2 here, negative 2, it's not a problem. But now we also realize that, hey, we have to exclude the negative 1. That's a bad thing into this function. So we put it all together. What we have, okay, let me just get this. So the domain of f of g of x is, okay, and I'm going to write an interval notation, negative infinity. No, negative infinity. I'm so used to writing negative infinity that's how it will start, but it's not. I need to look at my picture. I'm glad I wrote a picture. So it says start at negative 2. Head to negative 1, but don't include it. You need that. And after that, there doesn't seem to be any more problems. So I'm going to start with negative 1 and just head out to infinity. And there is my domain. Now, I'm going to show you what it looks like in Desmos, just so we can verify this. It's really nice having a ability to graph quickly these days. Okay, so I'm back to Desmos, and I've entered both of these functions separately for this example. 1 over x minus 1, you see it in red right here, so you see what it looks like in red. And the g of x, which is square root of x plus 2, you can see what it looks like here in blue. But of course, that's not what I'm really focusing on. You can see both domains in these two graphs that figured out. But what I want is the following. I want to take f and dump in g of x to create a new function. So now I'm going to click on these circles to take out the other functions. And now this is what f of g of x looks like. Okay. And if you look closely, it looks like it's correct. It looks like I'm starting here, just kind of, yep, at -2. Notice that the first variable is -2. I'm starting at -2. And then if I look closely, let me just go write the stop -1 was no good. So let me enter -1. And also I'm going to click here and by holding my mouse, I'm holding the mouse button down. It changes, so I can change this to a little, not a straight line, but kind of a dotted line so I can see where the break is. And sure enough, it looks like I go from -2 all the way to -1, but -1, there's a problem. Then it picks up on the other side and it continues like that forever, and there's no more problems after that point. Okay, but that's the resulting graph of the composition.